So this is the third lecture of algebraic topology. We were seeing the homotopy of paths or path homotopies, a definition, and we see the in second lecture the homotopy is the equivalence relation. So in this lecture we see the some examples related to path homotopic or homotopic of continuous maps as well. So first example, let's f and g are the continuous maps from x some x space to R2 or path homotopic. So there is a homotopy. So such type of homotopy h of x comma t is equal to 1 minus t of f of x, where f of x is a continuous function, and plus t of g of x, where f and g, as our supposition, f and g are the continuous maps from some space x to R2. So how can we write the homotopy when they are homotopic? So such type of homotopy h of x comma t is equal to 1 minus tf of x plus t into g of x. So if we substitute h of 0, if we substitute t is equal to 0, so we will get this term is 0. So we will get f of x, and if we substitute t is equal to 1, so we will get, so if we substitute t is equal to 1, so this term is 0, so we will get this term g of x. So if we write the diagram, so there is a continuous map f of f, so f of x, let's say this is f of x, and there is another continuous function g of x. So we can draw a line segment for each point of f of x to each point of g of x. We can draw a straight line for each point of f of x to each point of g of x. So we can translate, we can continuously deform f into g of x. So we can say this type of homotopy is straight line homotopy. Okay, this type of homotopy is straight line homotopy. So we are going to next example. Let's say x denote the puncture plane R2 minus 0. There is a diagram of R2 minus 0 is there is no place of this origin. Okay, so let's define a path f of s. We have a path f of s. So cos pi of s comma sin pi s. So let's another path have so g of s. So g of s equal to cos pi s comma 2 sin pi s. Okay. So substitute t is s is equal to, let's for f of s. So if we substitute 0, so we will get cos of 0 and sin of 0. So cos of 0 is equal to 1 and sin of 0 is equal to 0. So we will get this point. If we substitute and the place of s is equal to 1 upon 2 half, so cos pi by 2, and here is we will get sin pi by 2. According cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1. So we will get this point 1 upon 2. If we substitute 1 in the place of s, so we will get f of 1 is equal to cos pi is equal to minus 1 and sin pi is equal to 0. So we will get this point minus 1 comma 0 at s is equal to 1. This is 1 comma 0 as at x is s is equal to 0, and this point at 0 comma 1 at s is equal to half. So we will draw the path, this type of path. Okay, so now let's check for g of s. So substitute 0 at the place of s, g of 0. So g of 0 is equal to 0 comma 1, sorry, cos of 0 and sin of 0. So cos of 0 is equal to 1 and sin of 0 is equal to 1, 0. So we will get this point 1 comma 0. If we substitute half, so what we will get, so cos of half, cos pi by 2. So cos pi by 2 is equal to 0 and sin pi by 2 is equal to half. Oh, sorry, sin pi by 2 is equal to 1. So 2 multiply 1 is equal to 2. So we will get this point 0 comma 2. If we substitute in the place of s is equal to 1, so we will get cos pi and 2 sin pi. So cos pi is equal to -1 and sin pi is equal to 0. So this we get this point. So g, if we draw the graph of G. So this is G and this is F. So we can say, so F and G are homotopic. We can continuously deform F into G or G into F. So they both are path homotopic in R2. Okay, R2 minus 0. Okay. Let's define another path H of S. Let's define another path H of S. So what is the H of S? H of S is equal to cos pi s. So let's define another path and check is this path homotopic to f and g also. So this path defined as cos pi s minus comma minus sin pi s. Okay. So substitute s. So let's say h s is equal to 0. So h of 0 equal to cos of 0. Cos of 0 is equal to 1 and sin of 0 is equal to 0. So we will get this 0 comma 1. So we will get this point. So if we substitute half, so what we will get cos, in the place of this s is equal to half. So cos pi by 2, cos pi by 2 comma minus sin pi by 2. So according to cos pi by 2 is equal to 0 and minus sin pi by 2 is equal to 1. So minus 1 by 2. So we will get 0 comma minus pi is 0 minus 1. So we will get this point if we substitute 1 in the place of s in this function, this continuous map, this continuous path. So we will get what we will get. So h of 1 cos pi comma minus sin pi. So cos pi is equal to -1 and sin pi is equal to 0. So we will get this point. So this is the graph of h of s. Okay. So we can see, okay, you can see, and we also see this is the whole. So we cannot continuously deform f or g into h, or we cannot continuously deform h to f. So we can say H is not path homotopic, not homotopic to f or g. Okay, this is the example of this is the counter example, and this is the other example which is not homotopic. So H is not homotopic to f, also H is not homotopic to G. Okay, because at this point we cannot continuously deform F into H, or we cannot continuously deform G into H, because there is a hole, and we cannot go from another side, because they both are paths where initial and final points are same. So we cannot etch from this area and f, because there is a path, and as we know the definition of paths, the initial and final points are same for both or all of these paths. So we can say H is not homotopic to F and also G. Okay, Allah Hafiz. We will see in the next video, next topics in next videos. Please share, subscribe. Allah Hafiz.